Okay. And again, so let's keep everything in the chat primarily biology focused. And if there is anything that you would like to share, please send that to me if it is not biology related. All right. We like to save the chat as just a place where we encourage one another, and also participate in questions. All right. We had a great orientation last week, with all of our new students. They were there. Some of them are excited to be here. Some of them are hesitant. So we want to make this, yay. We want this to be a fun place for them to be. We had a great, like I said, we had a great meet and greet during orientation last week, and I told them how wonderful you all are and how much they're going to enjoy being here. Again, this is a place that we try to have fun. We also are trying to get ourselves focused in on what comes up in April. So we really only have, guys, we only have this month of February and then the month of March. All right. And we have spring break in March as well. So once we go on spring break, that pretty much cuts the ribbon of what we have, like our class time together to prepare for your, hey, good morning, Heba. um for what you are going to need to know for that end of state test. So we have to use these times that we have together strategically, and I hate that because I wish we could just hang out and chat all day, but that's not the case. Okay, awesome. So let's again just keep. Hey, Aria, I'm sorry you're having internet issues. Awesome. All right, let me check here. So in the help sessions, there's not like a scheduled agenda for the help sessions. That what's going to happen in the help sessions are those are like we could, if you have a topic you want to go over in those, we could. Those are typically more like, do you have a quiz question, a test question, content question? We can do test prep during then. However, on Mondays, I believe it's Mondays. I need to check our schedule. I believe it is Mondays that we are going to just checking chat here. I'm going to be doing test prep with Mrs. Sheets. Mrs. Sheets is awesome. Her job is to come in and help get you ready for that test. And so those sessions are once a week. And if you go, I'll just take you right now. Yep, those sessions are optional, but if I were you, I would pretend those sessions aren't optional. I would pretend those sessions are required because they're going to be that good, that it's going to be that meaningful to you. So let's go to the classroom really quick. I'm going to show you where to go if you want to find that information. All right, so here is our classroom. If you scroll down, all right, you're going to see today's agenda on the calendar. If you keep scrolling, there I am. There's our weekly announcements. And then test session and review materials. All right, this is where it talks about those things that we need to do to prepare for the test. So if you click on that, I'm hoping it'll download a link. See that? I don't think you can see that. It's going to download a link. And in that, it'll give you all kinds of hyperlinks. So if you're like, genetics was really hard for me. I want to go back and genetics is a area where we will be highly tested. If you're like, let's go do genetics, it will take you to a Kahoot for genetics. It will show you when the session is for genetics. It's really good. It's totally fine, Liliana. We're glad you're here. No worries. Oh, yeah, those are not, my emails are not checked through the OLS. They all go through a separate browser. That's not where I read mine. Awesome. So if you have any questions, just let me know, okay? And we are welcome to I'm happy to go through those materials with you. I sent out an email last week to all of your parents to just remind them that we do have that test coming up. And again, we have resources that are going to help you get ready. So don't stress, but just know our time here is precious. All right. And that's also why when you come early, that's where we do our social chatty part. And then when we get into classroom, then in our lessons, we really do try to get down to business pretty quickly. All right. So with that being said, let's go ahead and look at our goals for today. Um, is there someone who would like to read our goals? What in the world? These are kind of just going to give us a direction for the day as to what we're going to be doing in biology. So this is often a time that I think is a great opportunity for people to hop on their microphones and use their voices and still participate in class. Maybe since Pip did our emceeing at the beginning of class, I'll have Aria read our goals, and then Arya, can you also explain why our different goals are different colors right here and why they associate with this triangle?
Sure. So, what is natural selection? What are the three types of natural selection? What is genetic drift? And what is the difference between the bottleneck effect and the founder effect? And then oh, can you guys still hear me? Okay, it said I was disconnected. Okay, so this first one here is like darker blue, and it's kind of hard to tell, but I think that's knowledge. It looks like that's knowledge, and then what is genetic drift is also knowledge, and that's when we kind of just Mrs. Rittenhouse just teaches it for us, and we get to know what it means and just kind of figure it out and know more about it. And then the second one and last one, codes with understanding, and that's kind of like a deeper aspect of the lesson where we kind of do some practice questions and just review about it, and we get to understand it more and get to learn about it more.
Perfect job, Arya. So well. So just like you might build a house from the ground up when we come into class, Jake. We there. See, Jake even learned for the first time today. We are gonna learn for our content from the ground up. So what does that mean? That means that we get our baseline information that's down here, and as we go through the lesson, we build up. All right. So that up here evaluation, we're going to be doing things more like projects, you teaching, all of those kind of things. Awesome. Good job, Aria. Proud of you. And hopefully you're feeling better. Your voice sounds like you today. So hopefully that was good. Oh, good. That was a long, hard illness you were fighting. Really quick, because I didn't get to ask and I do care. Everybody type 1 or 2 words in chat. Oh, good enough to get on mic. Bless your heart. Tell me how you are feeling or what one thing you did this weekend. Tell me something about you. Good day, bad day. Pip is fantastic. We've got some tired. Jenna E. Sick. I'm sorry. Sleepy. Jayla feels good. Cleaning. Ooh, you went to Alabama? That's fun. Video games, tired. Ugh, I'm sorry. That's yucky, Justin. I hate that for you. Ooh, Amazon package to arrive. That's always fun. Sleepy, allergies. Our allergies have been weird around here too. Do you think it's the warmer weather? I don't know. Oh, that's cool, Jake. Cool, Kaden. Florida birthday. Florida! Liliana, where at in Florida? You have to tell me. You're just here. That's all right, Dustin. I'm just glad you're here. Well, we love pink. Allergies. Oh my word. I'm trying to keep up. Oh my word. Orlando. That sounds so much fun. Well, that will be an awesome week. Universal Studios. I've never been to Universal. Well, I think I went when as a child, but I have not been as an adult. That sounds like a lot of fun. Right now, we're Disney fans because we got, two princess lovers in the house. So awesome. Well, I'm glad we took that moment because I do care about all of you all and what's going on in your lives. And if there's ever anything you need, something more than you can put in chat, please email me. I'm here. I'd love to help and do whatever I can to come beside you and the things you're dealing with. All right. So we started our evolution unit. All right. To evolve means to what? Let's just go to the whiteboard for a minute. What does evolve mean? Just the word evolve. Nothing else. I just want you to tell me what the word evolve means. Why is it not doing what I want it to do? Adapt or grow, to change over time. Yes, to change over time. All right. And so last week we touched the surface of what evolution is. Lots of questions and lots of differences on like what you know about evolution, what you believe about evolution, a lot of intermixing of ideas, and that is great. Because guess what? You are a learner. And guess what? I'm a learner too. Okay. I'm a lifelong learner, and so are you. And so, some of these things, and if you are a scientist, you are a lifelong learner, because we don't know everything there is to know about everything, or we wouldn't still have jobs in biology and microbiology and anthropology and um, all of our different earth and physical and chemical and space and all the sciences, right? We still have people that is their job, is they go to work every day to become more specialized in what they research. And research is it's to do the scientific method and to learn what we don't know. So that is what we're looking at today, is what does it mean to change over time? What does it mean to grow? We talked about how part of that is adapting. All right. Somebody tell me if this happens from like over a long period of time or a short period of time. Do things evolve quickly or slowly? Some things adapt quickly, but they change slowly. All right. I like these answers. Good. All right. So today, what we're going to do is we're going to take that. All right. Evolve means to change over time. Right. We're going to take that principle and we're going to look at how things do change over time and some variations. All right. That's what we're going to look at today. So natural selection. I want you to type in chat, natural selection, and I don't care if you misspell it, just type it. Natural selection equals survival of the fittest. Survival of the fittest, all right? So I don't care what you think of in your mind to visualize. Like if it's just like who's the better person at thumb wars or arm wrestling. All right. Their nature chooses the winner based on the survival of the fittest. Who does the best in the environment that they are in? All right. That is what survival of the fittest is. It's a weeding out process. Okay. So, but can someone read what's in blue on the slide? Because I don't need to read. Pip, I promise I'll come back to you. I'm just trying to get different voices up here. Ireland, will you go ahead and read what's in blue?
Natural selection, survival of the fittest, the process of some factor in the environment favoring one group of individuals with one kind of allele over another group of individuals with a different kind of allele. This is the most powerful change over time.
Perfect. This is the most powerful change in a population over time. And it's basically nature playing a game of favoritism, right? I don't think favoritism is fun in life, right? We've all been there, right? Where you either were the favorite and things were great, or you were not the favorite and it kind of sucked, right? So that's what nature does, though. All right, they find what she said was a word called an allele. All right, allele. Maybe if you have not been in class with us for the first semester, you might need a little reminder, and maybe even if you were in class with us for a semester, you might need a reminder of what an allele is. What is an allele? What is an allele? Yes. Good. They're in your DNA. It is a gene in your DNA. I like that, Jake. Good, genes. Right. So for every characteristic, you have a trait. So let's say hair color. For your hair color, you have a trait. It's a little spot in your DNA. All right. It's what they call a band in your DNA. So if this is a band in your DNA right here, okay, that's the band we're looking at. We have one side of your DNA. All right, this is your double ladder. Oop, I lost it. This is your double ladder. This is the blue is your actual DNA unwound. All right. And the black is showing you that was not so pretty. I wanted that to look prettier. Let's get rid of it. And do another one. All right. Let's pretend. So there's the blue is your DNA. And this is a gene, a characteristic for a trait. All right. We're going to say this is the gene in your DNA for hair color. On one side of the DNA, you have one letter. On the other side of the DNA, you have another letter of the same number. So we're going to say we'll use the letter H for hair color. Okay. There are two versions of the H you can get. What are those two versions for that gene, for that trait? Yes. Perfect, Dustin. See, you're more than here. You're doing it today. All right. So you can have a big H. That would be an allele. All right. And you can have a little h. I'm going to put them outside of here because they're too big. All right. You can have a little h. Those are each, I might just, those are each alleles for a trait. One is dominant. Please point with, do you have your pointer thingies? Do I need to give them to you or do you have them? Yep. Use your point to the dominant allele. I know it's kind of tricky and hidden in there. Good. So the big H is our dominant allele and the little h is our what? Gonna point to the little h. It's our recessive allele. All right. So what does nature do? It chooses. It says, I like either the dominant or recessive allele, whatever it codes for, better. All right. And then that allele is favored in the population. All right. It's just playing a game of favorites. All right. and we're favoring one of those alleles, and over time we're going to see what happens. All right, so it says we talked about these funny crested fuzzy head birds before. Okay, so what happens over time to the arc crested fruit dove? All right, let's look down here. I know it's small, but like they both started out in the population. All right, this is the green-headed dove. This is the purple-headed dove. Which one was favored over time? The green, right? So over time, we see that that nature selected that green fuzzy top to be the more preferred dove phenotype. That's totally fine. All right. So do you see how that works? It favors that. And as one goes up, does the other go up too? No, the other one goes down. All right. And sometimes this is where you get where a trait completely leaves the population. And you'll actually see over time that you might eventually have no more purple-headed crested fruit doves. Because what happens is nature weeds out that allele because they weren't favored. All right. So natural selection is what?
Survival of the fittest.
Yes, type it in chat. Say it on your mic. Survival of the fittest. Natural selection equals survival of the fittest. Good, because we're going to remember that. Now we're going to learn 3 different ways that nature does that. There are 3 different methods, all right? Just like you can, this is your potato, all right? How can you cook your potato? Well, I can boil it on the stove. I can cook it in the oven, or I can put it in my air fryer, right? There are 3 different ways I can cook my potatoes. Okay, or microwave it. Okay. But just like there are options on how to cook a potato, there are different ways that nature can choose its favorite. So that's what we're going to look at today. We're going to look at the 3 different ways nature chooses. They're called directional, stabilizing, and disruptive. Directional, stabilizing, and disruptive. If you snip pictures for notes or draw your notes, this is a perfect one to do this for. Okay? Because these pictures mean something. Mrs. R put these pictures here very strategically. What do you think that directional is going to be about? If you had to guess, just based on the pictures. Ooh, one-sided. What goes up must come down. One-sided. That was well said and quickly thought of. Good. What about stabilizing? Balance. Overall. Okay. Anything else? Anybody else? Average. Calm. In place. Dustin, you have like... I just wonder sometimes how you... you must... Do you read ahead, Dustin? You're like super on target with your thoughts. Yes, I knew it. So does that help you though, Dustin? Do you feel like reading ahead does help you? Yes. Justin does too. I'm proud of you guys. I'm not proud of you if it doesn't, but see, I wondered, like everything Dustin says. I'm like, man, how did he know? All right, disruptive. I love that, Dustin. It's perfect. I know. This is what I feel like some days. Some hectic, chaotic. Good. I like these words that you're bringing. All right, so let's look and see how accurate we were. Okay. So directional selection. All right. One way nature chooses is directional. And directional means it favors one side or the other. Okay. One side. It favors one range. So I want you to put directional equals one-sided. That's why those arrows were there in this thing. All right. It either favors one side or the other. Not both. One side or the other. It favors the extreme. Okay. So it would be like saying it prefers blonde hair. Not like just blonde hair, not like honey blonde hair, like bleach, blonde, almost gray, white, platinum hair. All right. It favors the extreme. So in this diagram, you can see if this is all of your fur colors for mice. Okay. You have a few that are light, a few that are dark. The majority of the mice fur colors are right here in the middle. Okay. This is the original population. That over time, whew, look where that shifted. So this dotted line is where it used to be. Now, over time, this is where it is. So it favors that far dark, extreme mouse coat color. Does that make sense to everybody? Green check, red X. So directional favors one direction or the other. So what you'll see in the graph, if it's asking you this on your test, you're more than likely going to see a graph and you're going to see that shift from the middle, from like a normal population spread to far one side or far the other. And if you see that, what I want you to think in your mind, it is going in one direction, right? Directional, when nature chooses directional selection, by directional selection, it's far one side or far the other, one-sided. Okay, good. It looks like all of you are on the page with me. The second type of way that it's going to choose is stabilizing. All right, that was this. Stabilizing. I think about stabilizing. I think about, I'll have to show you tomorrow before class maybe, is like balance beam, right? When you're on a balance beam, you have to use your core muscles. Everything right in the middle, right? To stay on point. So that's what stabilizing muscle uses. If you're stabilizing your balance, you have to tighten your abs, tighten your core, and that'll hold you sturdy. And that's exactly what stabilizing natural selection does, okay? Again, the fur types of the mouse. If we look over time, we're going to see the shift. This is the middle. This is the core. It's centered. Right? Thinking about that yoga pose that was up here in the original slide. Stabilizing. Namaste. Right? Yep, it's thin. It's thin and it's in the middle. If you see that graph shift from wider to the middle, then that's going to be your indication for stabilizing. Just like when you balance, you stabilize at the center, at the core. When you have when nature chooses is stabilizing, yep, it likes that middle. So it doesn't like the extremes. It doesn't like this dark. It doesn't like the far light. It prefers, nature chooses the middle. That's perfect. Okay. So it goes from that spread original population to the center. Anytime you see that center get more narrow, I want your brain to go stabilizing. Okay. And the last, all right. And I guess this is my stabilizing example. I have to show it because it's one of my favorites, right? You've got your naked cat. You've got your extra fluff cat. And then in the middle, right, you've got Garfield. Right? It's that middle range. I know. It's funny, right? Got to mix it up. But that would be like a pictorial example of stabilizing. So the last would be disruptive. All right. Disruptive. You got this crazy girl here with like pulling her hair to both sides, like, whoa. Is that a good interpretation of that? Disruptive is literally disruptive. You got the pigtails. All right. See the pigtails? It takes the population. And if you could like push down my head and it goes to the side. So in disruptive selection, it's when nature chooses both extremes. I like to think about the methods of pigtails, right? It wants no average fur color. It either wants the far dark or the far light. You're going to notice that by the two humps. Anytime you see the two humps, you're like, that's crazy, right? It is disruptive, where it's not going to have one favorite. It's going to favor two different extremes. So directional chooses one side. Stabilizing chooses that middle average. And disruptive picks the extremes, both extremes. Right? Mother Nature cannot make up their mind. Mila, that is too much spray. My little waffle maker over there. All right. So in the case of the cats, if it would choose disruptively, it would be the naked and the extra fuzz. All right. That would be disruptive. So I want you to tell me, which one is this? Use your pointers. All right. This is blue is original. And nature picks towards one direction. Towards one direction. Good. That is directional. Good. So let's try again. What if this is the graph you see? I am centered. I am balancing. Good. Stabilizing, right? Nature is going to choose that middle core. That's your core. It's keeping you stable. Right there in the middle, and narrow section in the middle. What if it chooses the extremes? It'd be like, whoa, you crazy. I want the extremes, right? Got some crazy hair going. Disruptive. Yes. You guys are awesome. You guys are awesome. Okay. Oh my gosh. I have two more things I want to do. This is a quick check. I'm going to do this with you very quickly. All right. What type of selection is shown in the graph? We're seeing, here, let me do it this way because I'm trying to follow your arrows. Good. Everyone is peeing. I hope you're not all peeing. You're all pointing to directional selection. Wow. Mrs. Rittenhouse, you're going crazy today. All right. And let's check the next one. What factor is most likely a loss in genetic variation from a small population? It is genetic drift. I'm going to circle that one for you because we haven't hit that yet. Which term names the most power evolutionary force in large populations over time? There you go, pulling. Good. Natural selection. So the one we did not go over is the bottleneck effect. All right. So everybody knows what a bottle looks like, right? I wish I had one. Milo, is there a bottle in there you could pull out for me? No, like a little more narrow. What about the caramel coffee syrup? My coffee syrup, okay. This is the example. All right, this is a bottle. This is a bottle of caramel coffee syrup that I put in my coffee every day. So what happens is that what in the bottleneck effect is we're going to pretend this is full of beads. If I poured these all out at one time, because of the shape, the narrow neck of this bottle, which is wet, yuck, because of that narrow neck, when I would pour, oh, you have that too? This is some good stuff right here. 0 calorie caramel pecan, y'all. So as soon as you pour this, if it were full of beads and not caramel syrup, they would come out slowly. Now, would it spit out one of each color, like red, yellow, blue, green, red, yellow, blue, green? Would they pour out in order like that? No. All right, so sometimes what happens is there is a natural event that occurs, like flood, fire, volcano, tornado, whatever else it is, right? There's something that happens in our environment, and it does that. It does this to the population. That as that event comes, our population is weeded out. What's the word I want to use? With just randomly. And there is no reason that these blue and yellow beads down here came out, but there weren't very many green or red that came down here. You see that? It's random. Yeah. So sometimes life, like nature, happens and it randomly selects those alleles. All right. It's just whoever happened to survive. It wasn't because they were not necessarily the fittest. It's not because nature necessarily loved it that much. It's because something happened, and we call it the bottleneck effect. So I want you to think about that bottle. I want you to think about my caramel syrup, and how when you pour it out, it only lets out a few at one time, kind of slowly, right? And so you don't, it's randomly selection. And over time, look what happened. Because only these came out like fast enough before population started like reproducing, more of those blue and yellow populated over time, and it weeded out that red and green gene because nature randomly happened, right? The founder effect is another way that things happen randomly. All right. So this is something happens in the environment. This is the normal environment. And somehow one person either gets the boot or is the lucky one that gets to survive. All right. Let's just say an insect goes to an island with you on your jacket. You get there and it's only got one of its genetic variety because there's only like one or two of them, right? And so then they start to reproduce. And as they reproduce, they don't have any of this yellow genetic variation because they were isolated, right? Founder effect, I want you to think about isolated island. Okay, everyone type that. Isolated island. Isolated island. They founded it. It's an isolated island, and they're there, and they don't have a lot of choices. They're there with like whoever's there, and it's like, hey, I guess it's you and me, dude. So, want to make a family? And that's their only genetic variety that they get. They reproduce, they grow their families with whoever's there. They got limited choices of spouses. I know you do. I'm sorry. I'm going long. I didn't mean to go long. All right. I'm done. The good thing is we did our quick check first. I wanted you to have that done so you could take your quiz and feel amazing. You have multiple attempts. Get that done today. How do we feel? Do you know what natural selection is? Point yes or no.
I have a bit of a question, Mrs.
Natural
Rittenhouse.
selection is how things are selected over time. For those of you who are, for the one person hitting no. 1 second, Pip. All right. The 3 types of natural selection. How does nature choose? Directional, stabilizing, and disruptive. Bottleneck effect versus founder effect. We're going to randomly pour, and it's a slow pour, and only a few come out at a time, right? It's random. A natural disaster happened and only randomly chose a couple random genes. Or founder effect, 1 or 2 are isolated. Okay? You guys are awesome. You may leave. You are dismissed. I'm sorry, I went a little long. I promise I won't do it again.